Hey, Algebra 1, it's Mr. Florio. We got 5.3, insulin in the body. A patient who is diabetic receives 100 micrograms of insulin. The graph shows the amount of insulin in micrograms remaining in his bloodstream over time in minutes. So, right when they take the insulin, there's 100 micrograms, and then a minute later, there's only 90. 2 minutes later, there's 81, and in 3 minutes, there's 72.9 micrograms of insulin. Scientists have found that the amount of insulin in a patient's body changes exponentially. How can you check if this graph supports a scientist's claim? For this to be changing exponentially, the growth needs to be a factor. So I need to not be going down by a constant rate, but by a factor. So in what number am I multiplying 100 by to get to 90? And do I multiply 90 by that same number to get to 81? And do I multiply 81 by that same number to get to 72.9? So let's first find out what that factor is to go from 100 to 90. What am I multiplying 100 by to get to 90? And if I just take 90 and divide it by 100, that's going to be 0.9 or 9 tenths. So my factor, if I take 90% of 100, that'll give me 90. Let's see if I multiply 90 by 0.9 and get 81, etc. Where's my calculator? So if I take 90 and I multiply it by 0.9, I hope to get 81, and then that would be an indication that I might have exponential change. And I do. Okay. So if I multiply 81 by 0.9, do I get 72.9? So let's find out. Take 81, multiply that down by 0.9. And do I get 72.9? I do. Excellent. So we really do have exponential change here. So if I multiply all these numbers, 100 by 0.9, I get 90, times another 0.9, I get that, times another 0.9. So we have exponential change, and it's because everything is being changed by a factor of 0.9. So every minute, the amount of insulin in the bloodstream changes by a constant factor of 0.9 or 0.9 or 9 tenths. Right? How much insulin broke down in the first minute? What fraction of the original? Well, from the first minute, it went down from 100 to 90. So 10 micrograms broke down. In the first minute. And what fraction was that? So 10 micrograms broke down out of, it started with 100, right? And if we simplify that, that's just 1/10. So a tenth of the original amount has broken down. How much insulin broken down in the second minute? What fraction is that amount from 1 minute earlier? So in the second minute, we went from 90 to 81. So it looks like 9 micrograms broke down. So 9 broke down. What fraction is that? So that's 9 out of, well, from the previous minute, we started with 90, and then we went to 81. So we started with 90. So out of the 90 micrograms we had, 9 of them broke down. And we can simplify that to 1/10. Divide the top and bottom by 9, right? So 1/10, there's 1/10 of the micrograms left from the original. So 1/10 of the original. 1/10 of the micrograms broke down. And you could say that for number 2 as well. What fraction remains? So this is, we got to be careful. How much remains in the bloodstream? Well, if 1/10 of it went away each minute, then 9/10 remain. So 9/10 of the insulin remain in the bloodstream. And that's because since 1/10 broke down, 9/10 remains. Okay. Complete the table to show the predicted amount of insulin 4 and 5 minutes after the injection. So let's just continue the pattern. We know there was 100 micrograms after initially, and then a minute later, there's only 90 micrograms of insulin left. And then after 2 minutes, there's only 81 micrograms. At 3 minutes, 72.9. Remember, we're just multiplying all of these by 0.9. So just multiplying by 0.9 times 0.9. So I just need to multiply that number by 0.9. So 72.9 times 0.9, that's going to give me 65.61. And multiply that number by 0.9 again, 90% of that is going to be 59.049. So again, I'm just multiplying by 0.9 each time. Describe how you would find how many micrograms after 10 minutes. Well, I guess we could extend this table out to 10, or whatever number it is. So if it was to 20 or to 30, we'd have to just extend it out to that number. So there's two options here. We can extend the table out to 10 minutes because it stops at 5 minutes. What we're really doing is we're just taking the original amount, which is 100, and multiplying it by 0.9 a bunch of times. Times 0.9, 1, 2, 3, 4, 5. If I wanted to do it for 10 times, we're just multiplying by 0.9 10 times. In other words, it's going to be 100 times 0.9 to the 10th power, because 9 times 0.9 times 0.9 times 0.9, you multiply 0.9 by itself 10 times, that's 100 times 0.9 to the 10th. And it's not asking us, but let's see what that would be. So 100 times 0.9 to the 10th. So multiply 100 by, take 90% of 100 9 times. That's about, we'll say that's about 34.9 micrograms. If it was in n minutes, after n minutes, we just take 100 and multiply it by 0.9 m times. So if it's 10 times, it's to the 10th power. If it's 20 times, to the 20th power. And if it's m times, it's to the mth power, whatever m is. And I think, yeah. So, and that's it for the lesson. You can read the summary on the bottom, and just kind of does a similar example of this last one as, but instead of insulin, it's talking about caffeine in the body, which certainly applies to my life. But yeah, any questions, let us know. Shoot us an email. Thanks. Have a good one. Bye.